boost your overall model robustness. In this section, we will talk about validation dataset tuning, regularizing model to avoid overfitting, adversarial validation, and in the end, we'll perform metric selection on real data. In this video, we'll test a classic validation scheme. We'll use a k-fold cross-validation, and then we'll compare the result. The dataset is one from the BNP Paribas Cardiff Claims Management. Let's go to the code. I have imported all the necessary libraries, and as you can see, I have added a k-fold libraries, and that's all that I need in addition. So I have read the dataset, and I have taken the y value, which I would like to predict, and I have cleaned it and filled the NA, and I found the categorical features. That's the same as in the previous videos. And now we can talk about the basic validation scheme. So in basic validation scheme, you have to split your data into the train, test, and validation. So how usually it works? Suppose you have 1,000 samples, and in basic schemes you have a train set which is 70% or 700 rows. Then you have a validation split which is usually at 20%, and in our example it's 200 samples. And then the test one, that's usually 10%, it's hundreds of samples. And the idea that you are training your model on the train set and you tune it based on the validation set. So you train your model on 70% and you tune it for a last 20%. And then the final result is the result of your model for the 10%, which is from the test set and which the model and the algorithm has never seen. Well, it's a good principle, but the problem is that you just trained on the 70% of your data. And as we know, the more data, the better the result. It would be great if we can use all amount of our data, all the data, and not only the 70%. It would be great to use maybe 90 of them. So what I have performed, I have splitted my data in the train and test. So as you can see, the size of the test split is 10%, so the 90% is for the train. And then I split my train data, the train validation data, and I'm taking 25% of my train data. So 25% out of 90% is, well, just about 22.5%. And I'm building the basic algorithm. I stick to the cat boost because it's pretty good in this BNP Paribas challenge because of number of categorical features. I'm building the cat boost with the 100 estimators, and I feed it. The metric is AUG, and predict. And the score is 0.78, not that bad. But now I'm going to the k-fold validation. What's the main idea in k-fold validation? Suppose we would like to train on 90% of our data and just 10 test on the 10%. So we can split our training data in folds. Well, let's call it a fold. It's a subsample of the data. For example, in this case, in 10. And I can build the model on 9 folds and then tune and validate it on the last 10th. And then I can go next step. I'm taking another 9 and I train it again and I again validate it on another fold. And so I will repeat this manipulation 10 times. So actually I'll build 10 models and I'll build it on the data set of the 90%. Actually, I will receive 10 predictions from my original test set because I'll have 10 models. But in the end, I will train my models on the 90% of the data set and not on the 70. And then I can average the results for that test set and it will be my final prediction. So in a Python, there is a k-fold function which could be imported. It's a number of splits. And as you can see, there is a list there. I will store my predictions. There is a train test, y train, y test, and I'm splitting for 0.1. And for train and test and k-fold split, I'm just training a model. So I see it's train validation, test validation, why train validation, why test validation, and I will use it to build a model. And I'll build 10 models. And here is my prediction, and prediction starts in the prediction list. And at the end, the quality is much better, is 0.79. The only minus is that I have to spend 10 more times for training my models because I have to train 10 of them. But the result, the quality of this ensemble of models is much better, and well, I have used all the training data. Let's go back to the presentation. We learned the basic validation techniques, such as splitting in the train, test, and validation. And now we know that we could increase the train dataset with k-fold cross-validation and not to throw away 20% of our data to the validation set, but to use it. And the results are much better.